Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today I had the honor of addressing the Papa System radio club out in California on the subject of grounding and bonding. I thought what I'd do is go through those charts with you. My full video on grounding and bonding is Ask Dave number 8, which I discovered I did in 2015, so 5 years ago. Nothing really major has changed, although in that time the ARRL has come out with a book on the subject, which I reference in this video. So what I'm going to do is just narrate the same slides that I showed to the Papa System and hope that you find them to be of interest. Let's dive in. We start this discussion by looking at the very earth that we're talking about when we talk about grounding. This is ground. Ground on earth is actually electrically conductive. It does a pretty good job, and it's so big that it acts as the world's biggest counterpoise. And although this particular spot does not look like a good one for grounding, you could still put in a ground here. Either pound it through the rock or lay it on the ground and pile stuff all over it and do another one like it, something like that. And by the way, this is a picture of the Gunnison River up near where the Escalante Canyon crosses it. And that down there is a railroad line, not a road. So the point of grounding, or what is often called earthing, is to make sure that there is an attachment to the ground that our station system can use as a reference and also a sink for extraneous currents that we want to get rid of. One of the problems with ham radio, and I'll just show one right here, the wind creates static electricity on our antennas as it blows across them, particularly if it's exposed aluminum or exposed copper or something like that. If there is no path to ground, that static charge can build up and create a high voltage, which can then damage the radio's antenna leads and so on. Usually in the front end, there is some sort of a path to ground, but I did something once where I had a 2-meter radio that I had connected to a J-pole on the roof with no reference to ground. So all of that static electricity created a very high voltage on the front end of that radio and blew it out. And I had to send that radio back to ICOM to get it fixed. Other problems, of course, are lightning and that sort of thing. The idea is to keep the station referenced to Earth so that, well, there's quite a few benefits, as you'll see. Now, I point out this is a fairly standard way that we can ground. There's a ground going from a single point ground at the shack that goes down via a low resistance path to ground to a ground rod. Usually the ground rod is about 8 feet long. I happen to live in a house with a crawl space, so I just drill a hole in the floor here. I pull back the rug from the corner, drill a hole in the floor, and then later, if I need to, I can just push that rug back and it'll be just fine. Now, I mentioned low resistance. It should be a low resistance at RF as well as a low resistance at our 60 hertz utility power. So something like braid or copper strap or something like that that has lots of surface area, because as it turns out at RF, the RF energy travels on the surface of whatever conductor we have. Now, I said a couple important things here. One is station ground, that's the ground rod, and the other is the shack ground rod, which is a single point inside the station to which everything is grounded. That single point ground does not mean a single point literally, but can be something like a piece of 1-inch copper pipe or something like that, that is in the station attached to the back of your desk. I use hose clamps to attach the ground leads that go to, like, the power supply, the radio. I don't have a tuner in my setup right now, but when I do, I have it grounded in there. TNC would be grounded. Anything that you have should be grounded directly to this single point ground, not daisy chained, but attached to the single point ground. And then you have your low RF resistance connection from the ground rod, or from the single point ground down to the ground rod. I've got some do's and don'ts here. There are people, some who are prominent in ham radio, who would have you defeat the green wire ground on your power supply. I'm going to go opposite that and say do not defeat the green wire ground on any equipment, period. Now, this is the third wire in a 3-wire plug. You've got your 2 that bring the power, and then the thicker one that's round is the ground pin. Do not defeat that. And this especially refers to power supplies. Note that the DC negative coming out of your power supply, or the black wire, is likely connected to the green wire ground. This is a utility or 60 hertz ground and is not a substitute for a station ground. Do connect all your equipment, everything, to the shack single point ground. Connect the shack single point ground to the outside ground rod with a single RF-friendly connector like copper strap or braid or something. Copper strap is, we're seeing a lot of that more recently, and that's probably a better idea. And don't daisy chain grounds. Connect everything to the shack single point ground. Run all of your antenna leads to a lightning arrestor at your station ground rod and then into the shack. Do bond or connect your station ground rod to your utility ground rod with bare number 6 copper wire, buried preferably, and you can get that down at Home Depot or Lowe's. This is an example I'm going to give. This is a Butternut HF9V. I refurbished it one summer several years ago. It was quite a project. I took the thing completely apart, replaced one of these terribly expensive little capacitors you see at the bottom, and had that thing ready to go. And I hooked it up this way. The vertical was well grounded where it was because I had some buried bare radials that grounded it very well. And then I ran the coax to the radio, and it was noisy, very noisy. I think it had about S7 noise on the thing. And it was terrible. I said, this will never work. And then I had an idea. Why don't I ground the shield at the ground rod before I bring it into the shack? And that was before I had lightning arresters out there. The difference in noise was phenomenal. I went from S7 noise down to about S1 to S2 noise. In other words, it was just a dramatic improvement. I have a different vertical now. I have a step IR, big IR vertical, and in addition to those buried, a few buried radials, it also has a ground rod right there at it, and it has a bunch of radials that are on the surface, over 30, I think. And the antenna works extremely well. And it comes over to where at the ground rod, it actually goes through a lightning arrestor, and it's a very good, very low noise antenna. Works extremely well. A couple of don'ts. Here's an example of our copper water pipe. Our house is old enough to have a copper water pipe, but note that down at the bottom that it is connected to a plastic supply line. So the to ground to a water pipe, like they've been saying, historically to do, just doesn't do any good anymore. And now houses are no longer made with copper water pipes. They're made with plastic flexible pipe that goes throughout the entire house. Blue for the cold water and red for the hot water. And so there's no grounding value at all to go to water pipe. Also, be sure that you don't ground to your gas line. We have propane here, and you can see the rubber covered line down at the bottom there. No value as a ground rod. Plus, you don't want to do anything that could possibly, like if there was a nearby lightning strike, create a spark or something associated with that piping in the house. You just don't want to do that. Now, here's an example of a lightning arrestor setup. You'll note the ground rod going from the bottom of the picture up to the top. Up at the top is a stainless steel hose clamp that holds my station ground number 2 stranded wire, which goes all the way down to the ground rod, is crimping it to the ground. You want to do all of your grounding connections with crimp or snug fit tight connectors rather than doing any soldering. If you pass a lot of current, such as you might get during a nearby lightning strike, through something that is soldered, the wire's handling way more than its normal current, and it can actually vaporize the solder and it can go splattering everywhere, so don't want to do that. Everything is clamped here. This particular lightning arrestor mounting will handle 6. I believe this is actually from Alpha Delta. The lightning arresters are Alpha Delta, and the care and feeding of lightning arresters is actually quite easy. Note that these are commercially made. They're not amateur like something you might get from MFJ. These are the real thing that are used in commercial installations like cell phone towers and so on and so forth. They make them for PL259, and they'll have the SO239 on them. You can get them for end connectors, really about any kind of connector that you want. And then these are attached with stainless steel hardware to that copper pipe. You don't want to mix aluminum and copper. It doesn't mix very well. Try and get stainless steel between the aluminum and copper. I realize the purists will point out that stainless steel is not the perfect metal to put between aluminum and copper, but it certainly helps. Now here's an example of the wire that goes over to my utility ground for bonding to the utility ground. It's a thick, plain copper wire, and note that it is connected to the ground rod with this crimp connector. This connector is readily available at Home Depot. Go to Home Depot into the electrical section, find ground rods, and these little connectors will not be far away. You see also on there a strap that goes up to a VHF mast that actually is attached to the side of the deck. So this is how I ground that mast there. Now, if you want to get fancy, you can. KF7P, and you can go to kf7p.com, kilofox7papa.com, and they make these boxes that you can install that make the thing all a little bit more formal, neater. It gets your lightning arresters where you can see them easily. They also have blocks that they can put in there that will protect, like your wire, the wires that go to control the rotors on beams and things like that. Good thing to have. And note that very thick copper strap that's probably only 1 millimeter thick, but it's about 3 inches wide, and it goes down to the actual ground rod in the ground. Now, how does a lightning arrestor work? The way it works is that there's a little spark gap, and in the professional lightning arresters like the Alpha Delta, there's a little gas tube that has a spark gap in it, and it can fire many times over its lifetime. And it would, for example, if there's a nearby lightning strike, the spark gap will fire. And the thing about having the spark there is there's not a real big voltage across it. So it acts as the easiest way for the current to get to ground and protects your radio. Even the alpha delta coax switches that I have a spark gap in them. The little gas tube that you can put in there. The gas tube is designed that if it does fail, it will fail closed. So you'll try to operate, you'll discover an infinite SWR, and the first place to go look for something that high is to check that spark gap. The actual little gas plugs themselves are replaceable for $8 or $9, or you can get one with the screw-on cap for about $17 or $18. It's really cheap insurance for your radio. Now, I will point out that if you live in a lightning-prone area, you should probably keep your equipment disconnected, maybe even completely, in the event of a lightning strike, and then only install your equipment when you're actually going to operate. If it's the off season, you can leave it like this. I leave it like this pretty much all year. Now there are two values of those little gas tubes, one that can handle up to 200 watts. And if you put more than 200 watts in it, you run the risk of it firing and trying to protect your station. So they make another spark gap that will go up to 2,000 watts that you would use for those lightning arresters that handle your amplifier power. A spark is a steady flow of current through a very small resistance. When air ionizes and allows the spark to conduct, the resistance is pretty low. And so that's how that works. Now I want to talk about some documentation. The National Electric Code, and this is the 2020 edition shown from a website that's called electricallicenserenewal.com that will provide training and testing. This book is not free. It's in the order of $100 or more. Very often, although this is put out by a private organization, the National Fire Protection Agency, and it's interesting that they, of all people, would put out the National Electric Code. And they do that because this is from the insurance providers for fire insurance. They want your house to be built to best standards for electrical purposes to minimize the opportunity of a fire. Electrically induced fires were quite common 100 years ago, and they've all but disappeared today because we follow the National Electric Code. Very often your municipality or city will make a particular version of the National Electric Code mandatory. A new version is issued every year, but your local community might be a year or two behind. So you have to go with what they mandate. Now, of a more practical nature is a book called the Motorola Standards and Guidelines for Communication Sites. These are for major facilities like telephone companies, for those mountaintop repeaters that the Forest Service has or whatever. They're all put in according to this. And this is a very exacting set of guidelines that, if followed, can actually, in many cases, protect against a direct lightning strike. You'll see as an example there on the right-hand side of the globe, the ground wires coming from individual pieces of equipment inside a shelter to the shelter single point ground. And then a strap runs from that to the actual ground outside. Now the way they do these is very interesting. They actually will dig a trench all the way around the building or module or whatever it is, and run a ground wire all the way around the building. And then every 6 to 8 feet, they're going to put in ground rods. And then they will connect these to the wire using a little thing with thermite in it that will burn, and when it's done, it deposits copper between the copper ground rod and the copper wire and actually welds it together. Also, if you have towers, they talk about one ground rod per leg, and so on and so forth. Here is chapter 4 is on external grounding, sometimes called earthing. And you'll note it talks right away about lightning activity and exposure. Also 4.5 talks about dissimilar metals and things that can happen with that. And 4.6 is the bonding to the external, like utility ground system and so on. There are lots of ideas in here for ham radio operators. This is not mandatory, but it is full of very good ideas. Chapter 5 is internal grounding, like racks and stuff like that, bonding jumpers, this, that, and so forth, and they cover it in great detail. By the way, this book is commonly available online. The one that I got these pictures out of was the BLM, not Black Lives Matter, Bureau of Land Management website that has this on it, has the whole thing, has the 2005 version on it. Appendix C is about how to protect against electrostatic discharge in equipment rooms and so on, and talks about things like wrist straps, flooring chairs, things you can put on the desk, so on and so forth. You'll find it quite interesting. Also, in the last 5 years, the ARRL has come out with this book. Now, usually Ward Silver writes fairly conversational books, but in this book, what he's doing is summarizing the guidance that we have from both the national, the fire code, and also from the Motorola book, and shows how these things are put in and put together. This book is available on Kindle for $9.99, and it's worth a read going through, because it's a nice summary of things that apply to ham radio. So that concludes our slide presentation. Well, I hope that was enjoyable and maybe a little interesting about grounding and bonding. It's a very important topic, and judging from the questions I got today, one that hams are still struggling with. I know I did for many years. I think my station's pretty well done right now. I've got a few things still I want to do. I did do a video on the grounding system at N6GR in Albuquerque, New Mexico. That's Brad's system, and it's a fascinating things what he did. He went all the way. He did the kinds of things that you need to do in an extremely arid environment. Our environment here is not quite so arid, but we do live in an alpine desert. So, if you would please take a look at dcastler.com/support for ways that you can support this channel. I hope you will subscribe and click like, and also comment, if you would, on the video. If you have questions, leave them in the comments, and also click like, or dislike, I guess, whichever one works for you. So good to talk to you again. Until we next meet, 73.